Right, so while waiting for the other one, so right now we are 13, so yeah. So there's only one participant who wasn't able to join yet. So again, we're waiting for that one member. So do you guys have any other questions so far?
Wala naman po, sir. None,
Right.
sir.
Right. So right then. So he is now here. He or she, I don't know. Anyway, so let us now continue our discussion. So right here is 2010. Asking us to convert it to hexadecimal. So your divisor is 16. So 2010 divided by 16 is 125. We'll write it down here. And here. So we have here 2010 to base 12. So this one is decimal to n base. All right. So your divisor here is 12. So 2010 divided by 12, you will get 167 and then a remainder of 6. Okay. So if you're going to do this one on your calculator, 2010 divided by 12, you will get 167.5. Okay. And then just get the remainder or the fraction part. So 0.5 multiplied to the base 12, you will get 6 as your remainder. Right? Just keep on doing that 167 divided by 12, you will get 13 raised to 11. And then when you say base 12, it's actually a range of 0 to 11. Right? So since it's now reached the 10 and then 11, so we have to convert the 10 into A and then 11 into B. All right? That's why we have letter B in here. And then we have here 13 divided by 12 is 1. Remainder 1. 1 divided by 12 is cannot be, so just put here 0. And then whatever is the value of your numerator, just put it as your last remainder. And then just read this one from bottom to top. So 1, 1, B6. 1, 1, B6. Right? So are we clear so far regarding with decimal to n base? So guys, are you
Yes,
Yes,
guys?
sir.
sir.
All right.
Yes,
So
sir.
again, no matter what is the base, if it's binary, if it's hexadecimal, if it's decimal, if it's base 12, base 8, base 9. So just do this process, okay? And then you will not get an incorrect answer, okay? And then we have here exercises wherein supposedly will be your seat work if this one is a face-to-face method. So just do this one as your practice activity, okay? And then if ever you want me to verify your answer, whether your answer is correct or no, so just message me, okay? Just take a picture of your exercise or of this uh, let's say activity. So send it to me, and then I will check it, and then I will let you know if you've done the correct way or the incorrect way. All right? And then we have here conversion of decimal fractions to another basis, right? So this one is quite tricky already since it's a combination of a integer and then a fraction. However, it's still simple. Just follow the step, okay? So repeatedly multiply the given decimal fraction by the base. Could be 2, could be 8, could be 16, where you want it to be converted to, okay? and then separate the product's integer from its fractional part, and then record the product's integer. And then if the product's fractional part is already 0, write all the tallied products integers by reading them in downward direction. So if we have from bottom to top before, right now we have from top to bottom. Okay, so you will only do that one if we have a fraction decimal. Okay, so just to make this one clear, we have this example. So convert this fraction 0.625 base 10 to binary. Okay, so again, this one is your multiplier. So before we have the divisor, okay, for the integer part, but when it comes to decimal fraction, we have here multiplier. Okay, so your multiplier here is binary, which is 2. So 0.625 times 2 is 1, and then just put here the fraction part. So basically, you will get here 1.25. So yeah, just separate the integer part into or from the fraction part, which is right here. And then just copy the fraction part. Okay, so take note, it is now the fraction part that you are copying, not the integer part. Okay, so this one is the complete opposite of the integer part to the fraction part. Okay, if it's fraction, then you have to copy the fraction. If it's integer, then you have to copy the integer. So that's your uh, pattern or your tip, okay, on what is the one that you're going to copy. So 0.25 times 2, you will get, of course, 0.5. So 0 right here, and then 0.50 right here. And then 0.5 times 2, you'll get 1, and then, of course, 0 fraction. So again, you will only stop if you have here a fraction of or equal to 0. Okay. So before, we will only stop if we have a value of a 0 on integer, but right here, if we have a 0 of fraction. Okay. And then the one that you're going to get the answer with is, of course, integer part. So just read this one from top to bottom. So 0.101 base 2. So it is still in the form of fraction. Okay. So fraction, you have a result of fraction. Decimal, you have a result of binary. So are we clear so far?
Yes, sir.
Okay.
Yes, sir.
Okay. All right. So let's have another example. So this is another fraction, and then it's asking us to convert it to binary. So no problem. Just multiply everything by 2. So just copy this one to right here, 0.6875 times 2, you will get 1.375. So just copy the fraction, 0.375 times 2, you'll get 0.75. Okay, just copy this one, 0.75 times 2, you'll get 1.5. Just copy this 0.5. From here, you actually already know that you will already done with the process. So 0.5 times 2 is, of course, 1. They mean there are fraction 0. Okay, so once the fraction part is already 0, then that's the time that you will stop copying. Okay, and then just read this one from top to bottom. So 1, 0, 1, 1. Okay, so 0.1011 base 2. So clear? So nothing has changed, just the value. Same process, it's just the value. Are we clear with this one, guys?
Yes, sir.
Okay, just let me know if you guys are confused, okay? And then we have here another example, but this time it is now asking us to convert this one into octal. Okay, octal fraction. So just multiply that 1 to 8. That's the only thing that is now different. Okay, so 0.359375 times 8, you will get 2.875. Just copy this 0.875, multiply it by 8, you will get exactly 7. And since this one is already 0, then that's the time that we'll stop now. Just copy the integer product from top to bottom. So 0.27 base 8. So clear? Clear, guys? Okay ba tayo?
Yes, sir.
All right, so let's move on to the next one. So sometimes it's not only the fraction part, okay? It could be a combination of integer part and then a fraction part, okay? So this is a decimal wherein it is asking us to convert it to hexadecimal. So no problem. Just separate those two, okay, into two separate solutions. So one for the integer part and then one for the fraction part, okay? So for the integer part, so we have the divisor, he divided by 16. And then for the fraction part, you have here multiplier. So multiply it by 16. So you guys already know the process. So just keep on dividing this one until you will get a 0 for the integer part. And whatever is the result for the remainder, then that will be your answer for the integer part, which is BCF. And then right here, so once you have get a value of 0 on the fraction part, then that's the time that you will stop. And then just copy this one from top to bottom, the integer part. So 5, 2. So this one is 0.52. And then just combine those two. So BCF dot 52. All right. So it's just that a combined integer and fraction with the different solutions. So were you guys able to follow? All right. How about the others? Okay, so let me just ask 3 random people. Mr. Zedrex. Can you follow Mr. Zedrex?
Slide, sir.
Slide. Problema tayo sa slide na yan. Dapat pag slide, kanina ka pa nagtatanong. Okay, so just do a lot of self-study, okay? Kasi hindi ko na alam kung anong part ka hindi nakasunod. Hello, Mr. Zedrex.
Sir, sakto lang. Sir, wala. Sir, nasakto lang. Sinusundan ko din kasi sa computer, sir.
Okay. All right then. So, I trust you. How about Mini, Mini, Mo? Okay, Miss Antonio. Miss Eliza.
Yes, sir. Yes,
You're
sir.
going to follow? Is it clear?
Yes po.
Okay, good. How about Mr. Palaksa? Mr. Riddler?
Sir, nasusundan po.
Talaga, ah? All right. Okay, then. So if you guys were able to follow then I'm really, really happy. All right, so we have here some exercises wherein, of course, supposedly will be your sit work if this is a face-to-face setup. But then again, since we're not a face-to-face setup, you have to do this one as your practice exercise. Okay, so again, you can answer this one and then send a picture of this one to me, and then I'll verify whether you really done the correct answer or the correct process, right? So here's the summary, wherein you can convert the binary to decimal, binary to hexadecimal, and so on and so forth. So it's kind of messy, but those are the things that you can do, okay? So we have your hexadecimal to binary conversion. So this one is quite simple. You guys already have learned how to convert binary to decimal before, so it's the same method, okay? So 0 to 15. So as long as you guys know, this, let's say 4-bit, right? As long as you guys know this one, the value of the lowest bit is 1. The second one is 2, 4, and then the last one is 8. So if you're going to add all of those, you will get 15. So if everything is activated, it is now the letter F on the hexadecimal, right? And so on and so forth. Okay, so 0 to 15. So are we clear with this one so far? And how did we get those binary to hexadecimal?
Yes, sir.
Okay, so this one is similar with decimal, but in decimal, it's only 0 to 9. When it comes to hexadecimal, we now have A to F, or 10 to 15, okay, which is now this one, right? And then we have your hexadecimal to binary conversion. So this one is a lot easier than the conversion that we did before. So from here, all right. So from here, you could actually do this one by converting this bit by bit into a binary. Okay. So how will we do this one? So of course, we will start with lowest bit. Okay. Since it is asking us to convert it to binary, then as you guys may all know, binary is composed of zeros and ones only. Okay. So the equivalent value of a hexadecimal 5 to binary is, of course, so if have this cheat code. Okay. So 1, 2, 4, 8. So what is the number that I need to activate for me to get a value of 5? Starting from left. So how do you read that one? Anyone who wants to volunteer? And how do we convert this 5 into binary? What is our answer? Yeah, so very good, Mr. Audrey. So it's 0, 1, 0, 1. So this is now your 5. Okay, so why 0, 1, 0, 1? Since, of course, you have to activate 4 and 1 for you to have a value of 5, okay, which is now this one. How about letter F? Anyone? This is super easy. Yeah, it's 1, 1, 1, 1. Okay, just activate everything. Okay, so 8 plus 4 plus 2 plus 1, you'll get 15. Okay, or letter F in hexadecimal. How about A? What is letter A? A is 10. So what is A in binary? Anyone? Yeah, it's 1, 0, 1, 0. So very good again, Mr. Audrey. So very good also, Mr. Maswen before. So 1, 0, 1, 0, which is now your letter A. How about 1? So this is the easiest one. Kung ang sasagot, 0, 0, 1. Okay? Tagal niya eh. Okay? So voila, that is now your answer from hexadecimal to binary. Okay? And then you can actually reduce this one, okay, since the highest bit doesn't have a value. So you can remove those zeros and then just put here 1, 1, 0, 1, 0, 1, 1, 1, 1, 0, 1, 0, 1. Okay, base 2. So you can have this as your final answer, right? Which is now this one. Okay. So are we clear so far?
Clear, sir.
All right, so that's it for the answer of the number 1. How about this one? So base 16, then it wants us to convert it to binary. So no problem, just separate the integer to fraction, okay? Or you can actually do that one right away, where in letter D is 1, 1, 0, 1. So 1 plus 4 plus 8 is equal to 13. So if you're still confused, just always start with 10. Okay, so 10, and then this one is equal to A. 11 is equal to B. 12 is equal to C. And then 13 is equal to D. and so on and so forth until you reach 15, of course, which is letter F. 14 is letter E. Okay, so as long as you know where you will start, which is 10 is equal to 8, then you will not lost when it comes to solving, oops, what is this letter D? Oops, what is this letter E? Okay, so in that way, you'll be able to know that this one is 13. So for you to be able to have a 13 equivalence in binary, so it must be 1101. So 8 plus 4 plus 1 is equal to 13. Okay. So still the same process, just put your decimal, and then 6 is 011, so 4 plus 2. And then we have here 0, so just put here everything 0. And then the last one is 3, so 1 plus 2, okay, which is equal to 3. So from here, you can now remove the other 2, which will not affect our answer. So 11000, well, 0110.1101. Right? So are we clear so far with example number 2? Okay. Okay, so that's good that I'm now seeing Mr. Brian Tabiando giving me a thumbs up. Okay. Okay, so clear share coming from Mr. Audrey. Right, so very good. Then we have here binary to hexadecimal. So we can, of course, if we can convert binary to any number, we can also convert binary to hexadecimal. Okay, so binary to hexadecimal is just the opposite. Okay, so we'll be given by this number, and then it is asking us to convert this one into hexadecimal. Right? So this is very simple. So the first step that you need to do is separate those numbers by 4-bit, okay, to avoid confusion. So in here, so I guess no problem. So 0.1101. So this is already 4-bit. And then starting from the lowest bit of the integer part, so 1010 or 0101. 1010. Okay. And then for the next one, it's 1010. So 1010. 1, 2, 3, 4. 1, 2, 3, 4. Separate ko lang to. Okay. So 1, 2, 3, 4. Right here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. There you go. So we have here 1, 0, 0, 1. And then for the last two, we have 1, 1, and then we have an invisible 0, 0 right here. So 1, 1, 0, 0. Okay, so that's the first step that you need to do when it's asking you to convert a binary to a certain base. All right, and then the next thing that you need to do is, of course, get the hexadecimal value of this binary. Okay, so 1101 is equal to 8 plus 4 plus 1 is 13, wherein 13 is letter D. Okay, and then we have here 1010, wherein this one is equal to 5. So 4 plus 1. So 1 is also 5. And this one is 9. So 8 plus 1. And then the last binary number is 1, 1, which is 3. So 2 plus 1. So the answer for this one is 3955. That D. Huh? 1 CAA? 1, 2, 4.
Mali ba, sir?
Mali naman. Yeah, so the correct answer is 3955. Where did that 1 CAA.D came from? So you guys must start right here, okay? From the decimal part. And then separate it by 4. So I've already put here comma to avoid confusion kasi nakakaduling. So 1010, which is this one. and then 0101, which is this one, and then 1001, which is again this one, and then we have here 11 or 011. Okay, so the answer of Mr. Tabianda is correct. So 3955.b, okay, which is now this one. Right? So were you guys able to follow? At least 80%. So I guess that some of you are now confused. So are we clear? At least 50%? Hello guys.
Clear, sir.
Somehow.
Somehow, some way. All right, so let's have another example, of course, for us to have a clearer understanding when it comes to converting any base to binary. So we have here 17.5 base 8. So let me just copy this one and paste it right here so that we can have our own solution. All right, so we have here 0.5. But first, before we will convert this one, we have to know that a decimal to octal has a limitation. Okay, so 0 to 7 is the same with octal. Yeah. So no problem when it comes to 0 to 7. However, once we have a decimal of 8, in here it's already 10. Okay, if you have a value of, let's say, a decimal of 9, this one right here is already 11. And then up to 8 to 9, 8 to 17. There you go. So this one is up, is correct? 0 to 7 plus 7. No, sorry. This one is up to 15 only. This one is 11. So just keep on adding 2. So 15 plus 2, this one is up to 17. And then from here, you will jump to 20. So 20. Yeah, 20. Up to 27. And then from here, so it's now an additional of 4, I guess. If I'm not correct. If I'm correct, this is, I guess this one's 16. Let me just check. I think that one is 16. Octal, yeah, 16 to 20. Why do we have 15? 16 to 20. Really? 16 to 20. 15 to 17. We missed that one. 16 to 20. That's why there's something wrong. This here is 16 to 20. And then right here is plus 4 already. So 20. So if we have 17 plus 4, 21. And then up to 20. So 16 to 20 is up to 24. Really? Is it up to 20 only? No, sorry. This one is up to 7. Up to 23 actually. So just plus 4, 20, up to 27. All right. So yeah, and then 24 to 30. And then 31 to 37. So just keep on adding 7. Okay. And then on the right side, so it's incrementing by 2. So before we have plus 2, and then right now we have plus 4. Later on, we'll have plus 6. And then later on, you'll have plus 8. But anyway, that's already quite a long range of numbers. So you can just stop up to 15 actually, right here. So 0 to 15, and then 0 to 17. Just like in here, okay, wherein you have 5. So I guess no problem with that one. So for binary, we have here 0, 1, 0, 1. Okay, 4 and then 1. And then decimal right here. For the 7, so no problem. So it's still 1, 1, 1. Sorry. There is one thing that I forgot to mention. When it comes to octal, okay, so it is only 3-bit. All right. So 3-bit only. That's because 4-bit is 4 hexadecimal. So if you're going to take a look in this one, 0 is 0, 0, 0. 1 is 0, 0, 1. Up to, let's say 6 for now. So 6 is 1, 1, 0. And then for the 7, of course, it's 1, 1, 1. Okay. So as you guys can see, once we have reached 8, this one is not octal anymore. Okay. So at this point, you will get a total of 4 bits already. Okay. And then if we have 4-bit, this one is already covered by the hexadecimal. Okay. So that's why 3-bit only, that's for us to have a conversion of octal. Okay. So that's the separator between octal and hexadecimal. So octal is up to 3-bit only. And then if we have already 4-bit, then that's already hexadecimal. Or 9 base, yeah, 9 base, 10 base, 11 base, up to 15 base. Okay. It's already covered by 4 bits. But if it's up to octal only or 8 base, then that's 3-bit only, right? So right here, we have a 1, 1, 1, 0, 1. Okay, so 1, 2, 4. So 1 plus 4 is equal to 5. And then for the 7, of course, just activate everything. You'll get 1, 1, 1. And then for the 1, just activate the 1. So 1, 0, 0. Right? And of course, you can simplify this one a little bit more by removing the last 2, 0. So you will get 1, 1, 1, 1, that 1, 0, 1. So did you get the same answer? Where's that? Yeah. So 1, 1, 1, 1, that 1, 0, 1. 1, 1, 1, 1, that 1, 0, 1. All right. So are we clear so far regarding with octal to binary? So there is also a note here where it's 3 binary leaves. So not 4. Clear? Or you guys now are confused? Yes. Octal and below. Okay, so you can have 7 base, which is also 3-bit. Yeah, 6 base, 5th base, 4th base, 3rd base are all no, actually. But it's rare that you will have 1, 1 is 3. So if you have 3 base and below, okay, that's already 2-bit. If we have 4th base and above, up to 8, yeah, up to 8, this one is 3-bit. Okay, and then if we have 8 base to 16, this one is 4-bit. Okay, so this one could be, one, only one value. It's either a 0 or 1. So this one is only 1-bit, of course. Though, having a base of 1 to 3 is quite rare already. So I don't have that question on my quizzes or on your exam. Okay, but if ever you will encounter, let's say, 1 base, 2 base, 3 base, so there's the equivalent count of bit. All right. So this is 8. So any other question before we'll proceed to the next one? Binary to octal. Okay, so this is just another example, actually. All right, so if you guys don't have a question anymore, then this is another example wherein, you have to separate or you have to call this one. Anong tawag dito? You have to section them, okay, by 3. Or separate na nga lang. You have to separate them by 3 bit. So 1, 0, 1, which is this one. And then 1, 1, 0, which is this one, and then 101, 010, 100, and then 110. Of course, you have to add a 0 there. And then just, have your equivalent value to decimal. So 101 is 5, 011 is 3, 101 is 5, 010 is 2, 001 is 1, and then 011 is 3. Okay, base 8. Okay, so before, if we have binary to hexadecimal, then we have to separate the entire, let's say this entire binary number into 4-bit. But in binary to octal, you have to separate this one by 3. Right? So by 3-bit. That's it. So you have to group them by 3. Okay, so by 3, by 3, by 3, by 3. All right. So are we clear so far regarding with binary to octal? All right. So how about the others? Are you guys able to follow up to this point? All right. So I really hope that you guys are able to understand this one. Anyway, so here's the summary. So you can convert the decimal to binary, decimal to any base, etc., etc. So yeah, those are the things that you can do when it comes to conversion. So assignment, so yeah, no need. Okay, so I'll not do this one as your assignment anymore. So just do this one as your practice assignment. Okay, and then you can forward to me the picture of your solution or of your answer, so that you'll be able to know if you really get the correct answer or not. Okay. Right, so next one here is operations on numbers. But since we don't have enough time anymore, so we will just continue the rest tomorrow. All right, so I would like you guys to study slide 1 to 40. Okay, so just go back on those part if there is a part that you are confused, and do an advanced study also regarding with 41 slide up to 63. Okay, so that you guys are ready for question and answer tomorrow. Right? So see you guys tomorrow, and thank you guys for coming. So goodbye.
Thank you, sir.
Thank you for coming.
Yes, sir.
Thank you too.